Okay, I guess we'll go ahead and get started. My name is Bruce Phillips. I am a hydrologist and hydraulic engineer for PACE. I've worked in the industry for 35 years. My focus is on river systems, stormwater management. So I specialize just in water resources. I've also taught at Long Beach State for over 25 years. I teach undergraduate and graduate classes in water resources, hydrology, hydraulics. I've taught the PE exam review class for almost 30 years. I have my own set of notes, which are available to you. And we'll be using part of those. So these are engineering hydraulic review notes that I use in a lot of my classes at Long Beach State. It's pages. Of work problems. Organize similar to the workbook that you purchased with this class, but I offer these to you for free. So you just contact the IT specialist here and he'll provide you the PDF of that file. So if you want more problems or are really bored over the weekends, don't have anything else to do, you're more than welcome to do that. Also, you can always get hold of me. This is my email address at work. So I always have students email me, whether it's the PE exam or my classes at Long Beach. I try to respond quickly. I'm usually working almost every weekend anyways. So I'm happy to, if you have particular problems that you're working through and you want answers to, feel free to email me. I try to get back to you as quickly as possible. So this is my email address. I've also was in charge of writing the state exam for 11 years. So I was the chairman for writing the special engineers exam. So I know quite a bit about exam writing. And I've also developed multiple choice practice exam problems for you in the hydraulics component, which are contained in this book, and we'll go through those. And they're old exam problems that I've utilized, and they're similar to the breadth type problems that you'd get on the exam, and we can go through those also. So there's a lot of material that I try to prepare you for with regards to the exam. So the structure for today is that we'll start out with fluid properties in the workbook. Then we'll get into pipe flow, looking first at the energy requirements. So we'll look at the 3 basic laws we use in hydraulics, and we'll look at that application. First, we'll look at pressure flow. That's going to take us most of the morning. And then we'll get into open channel hydraulics. And then we'll get into culvert design, and then we'll look at some of the additional study aids and guides that I provided for you. Hopefully we'll get out of here by 4 o'clock, because I want to make sure I'm in there for kickoff for the USC-Stanford game, since I have 2 degrees from USC. So let's go ahead and get started. Are there any questions right now with regards to what we're going to cover or how to get hold of me? Okay. So first we're going to talk about the properties of fluids. And so we're generally looking at incompressible fluids. This semester I'm actually teaching fluid mechanics. So in the fall I always teach fluid mechanics at Long Beach State. And then in the spring semester usually I teach either senior level or graduate level courses in water resources design. So this works really well because I just had lectures all this week on just fluid properties. And the definition of a fluid is that if you applied a shear stress to it, that it continuously deforms. And what that means is that if we had a fluid element here, assuming that it could stand up as a cube, and you applied a shear stress. So it's not a normal pressure, but a shear stress, and that here's your surface so that you're shearing against. So you apply a shear stress to this element of fluid, it's going to deform. Whereas if this was a solid, there'd be a strain on it, but it wouldn't deform necessarily. So what happens, assuming that this is a fluid, it's going to move. So it deforms. And what happens that it starts moving. So in order to have movement in fluid, there's going to be some kind of shear that's moving it. And what happens is that, you know, if you looked at from the bottom surface here, so this is our surface, and we're applying this shear stress, and then here's your area. If you take the force divided by the area, that's your shear stress. So remember, for you structures people, that's force divided by the area. So we're applying our shear stress. So it's going to move. So what happens is that from the bottom here, the fluid actually sticks to the solid. So that's one of the basic properties of fluid motion, is that at a surface, right at that boundary condition, fluids stick to it. So if you have a ship moving along, the particle of water right next to the ship is moving at that velocity of the water. But if we have a stationary object like this, the velocity is 0. But as you get further away from the object, because of the shear stress, it's moving. And so if we plotted a velocity profile, it's going to look like this. And we'll talk about this later. This is going to become important to us. But I just wanted to talk about sort of what the definition of the fluid was. So there's two main categories, ideal and real fluids. We're going to be looking at fluids, and they follow essentially Newton's law. And they can either be incompressible or compressible. We're not looking at compressible fluids, gas in this particular case. We're looking at different types of fluid that are incompressible. So let's get into basic properties that we're going to use throughout today that are very important. First, we'll look at the weight properties. The weight properties, which you've seen in other classes, first we have the mass density. So this is the mass density. And so the mass density is the mass per unit volume. And for water, and we're going